This is the fourth part of the chapter real numbers. We will cover exercise 1.2 in this video. Okay, in the previous video we have covered the examples of irrational numbers, examples of how to prove an irrational number. Okay, let us do the questions. First one, prove that root 5 is irrational. Okay, for this kind of questions, proving any number as irrational, we have to follow the same process. Okay, first we have to assume the number is rational. Let root 5 is rational number. Let root 5 is rational number. So if it is rational, that means it can be expressed in the form of p by q. So root 5 is equal to p by q. Okay. See here, p and q are integers. P and q are integers. Here p and q have common factors. P and q have common factors. So divide, they have the common factor. Divide p and q with the common factor. P and q with the common factor. When you divide p and q with the common factor, you get, you get a number. For suppose, let it be a by b. Okay, so here a and b are co-primes. That means there is no common factor where a and b are co-primes. Where a and b are co-primes. Okay, so here root 5 is equal to a by b. So squaring on both sides. Squaring, when you do squaring on both sides, you get 5 is equal to a square by b square. You get 5 is equal to a square by b square. So a square is equal to 5b square. So this equation tells us that 5 divides a square. Okay, from theorem 1.2, from theorem 1.2, if p divides a square, then p divides a also. This implies 5 divides a. Okay, that is a by 5. Okay, let us assume this has some number x. Okay, a is equal to 5x. When you do squaring on both sides, you get a square is equal to 25x square. Okay, a square is equal to 25x square. See here, from this equation we have got a square equal to 5b square. When you substitute that, a square is 5b square is equal to 25x square. So here b square equal to 25 by 5 x square. So b square is equal to 5x square. Okay, see this equation tells us that 5 divides b square. 5 divides b square. So from theorem 1.2, if p divides a square, then p divides a also. This implies 5 divides b. See here we have got 5 divides B and 5 divides A. Okay, let this be first and second. Okay, see from 1 and 2, 5 divides A and B. 5 divides A and B both. That means A and B has a common factor 5. That means that is A and B have common factor 5. Okay, A and B have common factor 5. But here we have seen that A and B are co-primes. Here A and B are co-primes. Okay, this contradicts the statement that A and B are co-primes. Okay, so this contradiction has arisen because of our wrong assumption. Therefore, our assumption that root 5 is rational is wrong. Therefore, root 5 is irrational. Root 5 is irrational number. Okay. Next one. Prove that 3 plus 2 root 5 is irrational. Okay. The first step is assuming it is a rational number. Let 3 plus 2 root 5 is rational. So if it is rational, it will be expressed in the form of P by Q is equal to P by Q. P and Q are integers. P and Q are integers. So here 3 minus P by Q. Take P by Q to the left side and 2 root 5 to the right side. Okay. Now take minus 2 to the left side. Okay. 3 minus P by Q. This one whole divided by minus 2 is equal to root 5. Here minus, see minus will come to the numerator, 3 by 2. Okay, plus. Okay, let us take common, minus common, minus P by Q, 2. Okay, 2 is in the denominator. Okay, root 5. Or else you can, if you are confused, you can write like this. See, take 2 to the left side, so it will be divided minus half into 3 minus P by Q is equal to root 5. You multiply this one, minus 3 by 2 plus P by 2Q is equal to root 5. So here P by 2Q minus 3 by 2 is equal to root 5. So here P, Q, 3 and 2 are integers. So here as P, Q, 3 and 2 are integers, then P by 2Q minus 3 by 2 is equal to rational number. So here from this statement and from this statement, we can say that root 5 is rational. Root 5 is rational. See, if this one is equal to root 5 and the same is equal to rational. So root 5 is equal to rational. But this contradicts the fact that root 5 is irrational. Okay. This contradicts the fact that root 5 is irrational. Okay, this is the fact. Root 5 is irrational. Okay, this contradiction has arisen due to our wrong assumption. Therefore, this contradiction has arisen due to our wrong assumption. Therefore, 3 plus 2 root 5 is irrational. Okay, next one. Prove the following are irrational. Okay, first one, 1 by root 2. Okay, first step is assuming that it is rational. Assume 1 by root 2 is equal to rational. So if it is rational, it will be expressed in the form of p by q. Here p and q are integers. So take p by q to the left side, that is q by p. Take 1 by root 2 to the right side. So q by p is equal to root 2. So as q and p are integers, then q by p is a rational number. When you divide q by p, you will get answer as rational number. You will get a rational number as answer. Okay. So from this, from first and second, you get root 2 is rational number. Root 2 is rational number. Okay, but this contradicts the fact that root 2 is irrational. Okay, this contradicts the fact that root 2 is irrational number. Okay, so this contradiction has arisen due to our wrong assumption that root 2 is rational. Okay, assumption is wrong. Therefore root 2 is irrational. See, if you have a single numbers like root 2, root 3, root 5, root 7, then you have to do the long process that p and q are integers, and then you have a common factor, you divide with the common factor, and then it becomes a rational number. Numerator and denominator both are co-primes, and you have to prove that as long method. And if you have something like multiplication and division with these irrational numbers, or addition or subtraction, you can do this one. Here on one side you have to bring one irrational number, and the other side you have to multiply or divide or add or subtract the integers. Then both will have contradiction. Okay, the next one, we have to prove 7 root 5 as irrational. Okay, let us assume that 7 root 5 is rational. assume that 7 root 5 is rational number. So 7 root 5 can be expressed in the terms of P by Q. Okay. See, here we have this multiplication 7 into root 5. Okay. We don't have to do the long method. Here P and Q are integers. P and Q are integers. Okay. We don't have to assume that they both have common factor and divide. We don't have to do that. Okay. Now here 7, take 7 to the right side. Okay. Root 5 is equal to P by 7Q. Okay. P by 7Q. See here, as P, 7 and Q are integers, P, 7 and Q are integers, then P by 7Q is rational number. P by 7Q is rational number. Okay. Now take this as first and take this as second equation. From first and second equation, P by 7Q is equal to root 5 is equal to rational number. This implies root 5 is rational number. From this all statements, we have drawn that root 5 is rational number. But this contradicts the fact that, root 5 is irrational number. The fact is root 5 is irrational number. So this contradiction has arisen because of our wrong assumption. Therefore, our assumption is wrong. Therefore, 7 root 5 is irrational. 7 root 5 is irrational number. Okay. Next one, last. 6 plus root 2 is irrational. We have to prove that 6 plus root 2 is irrational. Let us assume that 6 plus root 2 is rational. Assume 6 plus root 2 is rational number. So, rational number means it can be expressed in the form of P by Q. Here P and Q are integers. P and Q are integers. Okay. Take 6 to the right side. Root 2 is equal to P by Q minus 6. Okay. See, make this as first equation. Here P, Q and 6 are integers. So, P by Q minus 6 is equal to rational number. Okay. This is second equation. From first and second equation, we can draw that, we can come to a conclusion that P by Q minus 6 is equal to root 2 is equal to rational number. This implies root 2 is rational number. So this contradicts the statement. This contradicts the statement that Root 2 is irrational, right? Root 2 is irrational. So this contradiction has arisen. This contradiction has arisen due to the wrong assumption. What is the wrong assumption we have done? 6 plus root 2 is rational. Okay. So therefore 6 plus root 2 is irrational. 6 plus root 2 is irrational. Okay. This is the end of the exercise 1.2, and with this the chapter covered in the NCERT is finished. Okay, for practice we will do more questions. Thank you.